Okay, Bismillah Rahman Rahim. Today we have the second lecture regarding distributed database environment. And in the first lecture, we have gone through with the introduction of word DDBS, word DDBMS is, and we have talked about the promises of distributed database environment. And now we'll move forward, and here we will discuss the concept of transparency. And as we have discussed earlier on, the transparency in the distributed environment refers to three kinds of transparencies. Number one, it is called a network transparency. Number two, it is called replication transparency. And number three, it is called fragmentation transparency. Transparency means that hiding the details from the users, or separating the higher level details with the lower level implementation details. So that is the concept of transparency. Or in other words, you can also say that in a distributed environment, whenever we are providing accessibility to the users will access the database in the same manner as they were doing in a simple client server environment, or they were doing in the simple desktop environment. So they don't need to they don't need to know how the network is distributed, how the replication is done, how the fragmentation is carried out. So that is the concept of the transparency, which is very important. Otherwise, if we are using any remote file systems, then that transparency is not there. So the first concept is regarding data independence, which is a very important concept for the relational database environment, that we have to provide data independence as we did जब हम एक simple client server applications बना रहे थे relational database को सामने रखते हुए. And data independence is the concept which says that how you can separate the data with the application, and the relational database provide this environment to us, and we can implement this by using three schema architecture. So in the three schema architecture, as you know, we have the external, conceptual and internal schemas. So we will provide that mapping of conceptual schema with the external schema, and also the mapping of the physical schema, the internal schema with the conceptual schema. So the network transparency means the distribution transparency, how nodes are distributed, how the various nodes are defined over a network. And for example, on which node actually your database is residing. So the users have no idea about it. The ordinary users normally access that data, but that network itself is transparent to them. And that is, in other words, we also say it distribution transparency, or you can say location transparency as well. And in other words, you can also say fragmentation transparency, which is discussed in the fourth point. Replication, and what is the difference between replication and fragmentation, we have discussed in the previous lecture as well. Whenever we say a replication refers to the copy of the database which is being provided at any node. That refers to a replication. And we have discussed earlier on that there are two possibilities: either we go for full replication or we go for partial replication. So if we go for full replication, it means a complete copy of the database is residing somewhere on the network on any other node. If that is the case, that is called full replication. And let's suppose if we have the fragments. Fragments refers to what? Fragments refers to how your database is divided, how you have divided your database. Basically, when you do so, it means you made the fragments. Because we are talking about the relational database environment. So in the relation database environment, the relation is a key, because the basic structure is the relation. So whenever you go for fragmentation in relational database environment, it means that you have to break the relation. So you have to break the relation either vertically or horizontally. So if you go for the horizontal fragmentation, or in other words, normally we say horizontal slicing. So if you do go for horizontal slicing, it means that you are dividing the relation. You are dividing the relation in terms of records. And if you are slicing a relation vertically, then it means you are breaking the relation in terms of attributes, because every relation carries some attributes. So let's suppose a relation, employee relation has 9 attributes. So after your assessment, after your requirement gathering, you believe that vertical fragmentation is necessary. And then what you did is, you, after finding out all the statistics, you come out with a design policy or design where you have divided the relation into 2 or more relation in terms of an attributes. If you do so, it means you did the vertical fragmentation. So even if the fragmentation is there, there is a fragmentation transparency. User have no idea what are the fragments, where these fragments are located. Okay. Similarly, in the case of replication, what is the replication strategy and how the replication is done? Which nodes are there where we have the replicated data? So that is the concept of transparency. Next concept is regarding reliability through transactions. As we have discussed that one of the promises of a distributed environment is to provide you the reliable system. And reliability refers to what? Reliability refers to failure-free operations. Let's suppose in any application or even in hardware device, if you are looking for a reliable device or reliable software or reliable database or reliable application, it means that you are talking about failure-free operations. So how it is being done? It is in this environment, that is through transactions, because as you know that whenever you are talking about database systems, there you have to perform, actually the transactions are being performed. And when I say a database transaction, it means a bundle of activities which can perform a certain task. Uh, One concept is a single activity. When I say a transaction, it means a bundle of activities, 4 activities combined together to form a transaction. Let's suppose that you carry data from one place and you did some computation and then you added it to somewhere else. Normally we termed it as a transaction. And whenever we are looking forward for to know that how database is being used, so we have to go through with the data regarding transactions. How many transactions are being performed? What type of transactions are being performed? Who have generated those transactions? What is the average daily transactions? What are the average transactions from each node? So on and so forth, because that tells us what is the traffic on the database. And of course, as number of transactions increase over a period of time, there is a burden on your application as well. So you are designing your system in such a manner that you can provide the optimal results, the best possible results in a given environment. So replicated components and data should make distributed DBMS more reliable. Of course, the reliability increased when you have a proper distributed DBMS, because otherwise, if it is not a proper distributed environment, then the total dependence is based on a centralized server or a node, which is, of course, in terms of reliability, यहाँ पर issues आएंगे, problems आएंगी, यहाँ पर reliability बढ़ जाती है because the responsibility is shared among various nodes. Okay, and the task can be done by sharing those resources, and you provide better access mechanism to your users rather than in a centralized environment. Distributed transactions provide 2 important things. Number one is concurrency transparency, because whenever the transaction is being carried out, always remember that, as I told you earlier, that a transaction itself is a bundle of activities. So a bundle of activities can be performed in 2 manners, in 2 ways. One is that it goes sequential, and one is that it goes concurrent or parallel. So the advantage of distributed environment is that all those transactions can be processed by concurrent access or a parallel access. So whatever the transactions are being done, it gives you a concurrency transparency as well, and you can your transaction can be divided into various transactions which can be carried out according to the your design. Then it always provide you a failure atomicity. As you know that अगर आपको याद है आपने डेटाबेस ट्रांजैक्शंस पढ़ी हैं तो डेटाबेस ट्रांजैक्शंस के कुछ खास चीज़ें होती हैं, कुछ प्रॉपर्टीज होती हैं। अगर आपको याद हो, आपने पुराने कोर्स में पढ़ा हो, तो इसको हम कहते हैं एसिड, ACID। और अगर नहीं पढ़ा तो इसे पढ़िएगा, आज लेक्चर के बाद जाके तलाश कीजिएगा कि डेटाबेस ट्रांजैक्शंस में एसिड क्या चीज़ है, क्योंकि इसका जानना आपके लिए बहुत ज़रूरी है। ACID ये एक्रोनियम है, ये 4 चीज़ों से मिलकर बनता है। ज़रा ये पढ़ के आइएगा, नेक्स्ट टाइम मैं आपसे पूछूंगा। तो इसमें एक कॉन्सेप्ट ये है, फेलियर ट्रांजैक्शन इज फेल्ड इफ वन ऑफ द नोड इज फेल्ड, if one of the activities failed, because you are making a transaction which is a bundle of activities, which is a set of activities. So उस पूरी set में से अगर एक activity fail हो गई, मसलन let's suppose if I ask you to make a transaction by taking an amount from one account and taking an amount from another account and put that amount in a third account, so it's a transaction. But let's suppose that amount is not available in the second account, the transaction will fail. That is the concept which is very important in terms of a database transaction. So it provides you a failure atomicity. Atomicity means that further it is not breakable. So a failure node at any point in time, it provides you with the failure atomicity. Distributed transaction support requires implementation of some kind of protocols. When I say protocols, it always refers you to the nodes. To the rules. Protocol refers to a certain rules. So how that concurrency can be achieved in a distributed database environment? So it is achieved through a certain protocols. One of the important protocol is called commit protocols. So whenever you talk about a database transaction, it refers to few things, as I given you one assignment, that is what transactions are, and in a normal in a simple database environment, and what is ACID. Similarly, there are certain things which are related to transactions. There are transactions जो हैं उसमें we use commit, we use rollback transactions. Whenever I say commit, it means that transaction can be done. एंड कमिट जब हम करते हैं तो कमिट कब करेंगे? क्या कमिट हम उस वक्त करेंगे जब ये तमाम चीजें अचीव हो चुकी होंगी, क्योंकि मल्टी यूजर इन्वायरमेंट है, मल्टी यूजर एक्सेस है, तो ये उसमें डर्टी रीड्स भी होंगे, डर्टी राइट्स भी होंगे. दैट इज ऑल रिलेटेड टू ट्रांजेक्शंस व्हिच इज अ पार्ट ऑफ योर फर्स्ट कोर्स. पहले कोर्स का पार्ट है और आप लोगों ने पढ़ा होगा. तो ये जो पहले उसमें ट्रांजेक्शंस के अंदर ये बड़ा इंपॉर्टेंट होता है. डर्टी रीड्स का तस्वर क्या है? व्हाट इज अ डर्टी रीड? मतलब ये है कि एक ट्रांजैक्शन परफॉर्म हो रही है, मल्टी यूजर एनवायरनमेंट है, मैं उस टेबल को एक्सेस कर रहा हूँ, आप भी उस टेबल को एक्सेस कर रहे हैं, ठीक है. आप उस टेबल में कोई चेंज परफॉर्म करना चाहते हैं थ्रू अ ट्रांजैक्शन, ठीक है. और इस दौरान जो है वो मैं उसको एक्सेस कर रहा हूँ. अगर ऐसा है तो जब तक कि मेरी एक्सेसिबिलिटी है तो वो डर्टी रीड कहलाता है, ठीक है. सो इसी तरह राइट है, जब आप राइट कराने जा रहे होते हैं तो दूसरे की जो एक्सेसिबिलिटी है वो, तो इस वजह से क्या होता है, कुछ प्रोटोकॉल्स आपको इम्प्लीमेंट करने पड़ते हैं. If you do not implement those protocols, those rules, then that concurrency cannot be achieved. तो फिर आपको रूल बनाने पड़ेंगे. अच्छा, जब ये एक्सेस करेगा तो मुझे इसको ब्लॉक करना पड़ेगा, जब ये इसको एक्सेस कर रहा है और ट्रांजैक्शन डन होने जा रही है तो मुझे दूसरे यूजर्स के लिए इसको ब्लॉक करना पड़ेगा, so on and so forth. So there are certain ways by which we can control those concurrent transactions. So for that purpose there is some sort of protocols जिनको हम कमिट प्रोटोकॉल्स कहते हैं. फिर उसके अंदर टू वे कमिट प्रोटोकॉल भी आता है, एंड ताकि मेक श्योर करें कि ये ट्रांजैक्शन जो है ना कमिट हो गई है और जो चेंजेस परफॉर्म होनी थी वो चेंजेस हो गई हैं, ठीक है. Data replication, as we have discussed earlier on, that data replication refers to the great for read intensive workloads, problematic for updates. जब भी हम रेप्लिकेशन की बात करते हैं, याद करें रेप्लिकेशन इज सुटेबल इन अ सर्टेन एनवायरनमेंट. It is not recommendable that in every situation, wherever you are analyzing the systems, you go for replication. So replication itself, you have to assess that what kind of transactions are being carried out, what type of applications have been generated from various nodes, what type of queries have been generated from various nodes. So that is basically, that tells you that whether the replication suits that particular environment. तो replication कहाँ सूट करती है? In short, replication वहाँ सूट करती है जहाँ most of the users most of the time access most of the data. Then replication is, you can say, can be considered. Number one. Number two, replication is suitable where number of updates are less. Or in other words, if you take the ratio of the update queries or update applications with the read-only applications, then if that ratio is low, then data replication is applicable. Or in short मैं ये कह सकता हूँ कि जहाँ पे read intensive या read only queries जो हैं वो ज़्यादा हैं comparatively, वहाँ पे आप रेप्लिकेशन को कंसीडर कर सकते हैं. और अपडेट की केस में क्यों बहुत ज्यादा अपडेट अगर है तो रिकमेंडेबल नहीं है. व्हाई? बिकॉज रेप्लिकेशन टेक्स टाइम. बिकॉज रेप्लिकेशन, since replication is a copy of a particular application, so that takes time to synchronize. So whenever we have replication, it means the sync operation is carried out, and whenever the sync operation is carried out, it takes a little time. So it makes the system slow. So best is that if you have more read intensive data, then you go for replication. That better suits you. Okay, and if you want to implement the replication, then there are replication protocols. Not only the replication protocols, but also in the products which you are using, whatever the products you have, in all those products, they have a proper replication manager, and you can use that replication manager to perform that replication or to implement that replication. So for that purpose, we also have some protocols. We also have some rules. Whenever we allow replication, फिर मुझे बताना पड़ेगा कि replication कब होगी, ये sync operation कब होगा, replication के लिए वो किस node पे रखा जाएगा, ठीक है? So on and so forth. So for that purpose, you have to follow certain replication protocols. Okay. Potentially improved performance, as we have also discussed, one of the promises that performance is increased. So as reliability is increased. So what is performance? How you measure a performance? Performance can be measured. Performance can easily be evaluated and it is by quantifiable operations, by quantifiable data, because we can see how many transactions are being performed, how much time is consumed, how much operations are being performed. So we can easily find out how the system is performing. Okay, so proximity of data to its points of use. The best thing is why the performance is improved, that we have the proximity of data. Proximity of data means that we have distributed the data in such a manner that data is accessible from where it is required. The proximity is there. Centralized environment में तो proximity है ही नहीं ना, हम तो एक ही जगह सारा सर्वर पे एप्लीकेशन को रखते हैं, सब उसको एक्सेस कर रहे हैं, तो proximity तो है ही नहीं. यहाँ पे that is the concept of proximity, because all those people, all those users on a particular node, they have that data which is required for them. So they have easier accessibility to the data. That data is actually available to them, accessible to them. Requires some support for fragmentation and replication. That is fine. We have already discussed parallelism in execution. Now, how that execution provides you the parallelism? How that execution provides you the concurrent mechanism? सो पैरेललिज्म ये बात तो मेक श्योर करता है कि जो पैरेललिज्म का जो कॉन्सेप्ट है या कंकरेंसी का जो कॉन्सेप्ट है वो हमेशा क्या करता है, वो आपकी परफॉर्मेंस को तो बेहतर ही करेगा ना। यानी एक चीज अगर मैं डिस्ट्रीब्यूट कर दूं मुख्तलिफ पार्ट्स में और वो सारे पार्ट्स एक ही वक्त में परफॉर्म हो रहे हैं, तो ऑफ कोर्स दैट विल इंप्रूव द परफॉर्मेंस. So parallelism in execution means two types of parallelism in this context. One is called interquery parallelism and second is called intraquery parallelism. Interquery parallelism means that let's suppose a user has generated a query from any site, and that query, let's suppose it's a complex query which might have certain dimensions. We might have some subquery as well. So your query will be divided into 3, 4 or 5 parts, and all these 3, 4 and 5 executions will be done in parallel rather than sequentially. तो क्वेरी को ब्रेक करना, क्वेरी को ब्रेक करके एक साथ कंकरेंटली उसको एक्सेस करना, ये आपको एडवांटेज है whenever you talk about parallelism in terms of interquery parallelism. और intraquery parallelism क्या है कि एक तो ये parallelism चल रहा है जो within a query है, और intraquery parallelism means that there are multiple users who are accessing that data. So at one point in time there is not a single query, there are multiple queries. So the multiple queries which are being carried out, those queries are also in parallel. So query itself is divided into some subparts and executed in concurrent. And secondly, various queries have been generated by multiple users. So all those queries will also be done in parallel rather than sequentially. So therefore, we can say that parallelism exists in two ways, that is interquery parallelism and the intraquery parallelism. तो दोनों parallelisms यहाँ पे exist करते हैं. Okay जी. How much how have as much of data required? So parallelism requirement means have as much of the data required by each application at the site where the application executes. That is the key. That how have as much of the data required, वो सब data जो required है by a particular application at the site where the application execute, जहाँ पे application execute कर रही है, क्या वहाँ पे maximum data available है? ऐसा है. किस केस में होगा? ऐसा होगा in the case of full replication, because in the case of full replication we have all the data available at that particular point in time. ठीक है? So how about updates? So the main important thing is updates. क्योंकि जब आप replication करते हो, in the case of replication the most important thing is that how you perform the updates, because as we know that in the case of replication, whenever you have various updates in the databases, that has to be synchronized, है ना. अब synchronization दो तरीके से हो सकती है. एक तो हो सकती है mutual consistency, यानी जैसे जैसे मैं इसको वेरीफाई करता जा रहा हूँ, जैसे जैसे मैं इसको अपडेट करता जा रहा हूँ, म्यूचुअली मेरी जो रेप्लिकेटेड साइट है वो उसको साथ साथ अपडेट करे. और दूसरा जो कॉन्सेप्ट है जो हम इस्तेमाल करते हैं, ऑफ कोर्स पहला वाले कॉन्सेप्ट के एडवांटेजेस भी हैं, डिसएडवांटेजेस भी हैं. डिसएडवांटेजेस में ये है कि इट टेक्स मोर टाइम, इट टेक्स मोर एफर्ट्स. So that is the issue with such kind of updates. And the second is regarding the freshness of copies. That is the other principle we have. So in case of freshness of copies, normally that process is being done with some gap. इसमें हम क्या करते हैं कि थोड़ा एक टाइम के बाद सिंक्रोनाइजेशन परफॉर्म करते हैं. अक्सर आपने देखा होगा, हम भी बहुत सारी एप्लीकेशंस गूगल पे यूज कर रहे होते हैं जहां हमने सिंक कराया हुआ होता है. तो जरूरी नहीं होता कि जैसे ही मैं अपडेट परफॉर्म करूं वहां सिंक हो जाए. तो बाद दफा कुछ टाइम में सिंक होता है. बाद दफा मैंने अपनी एप्लीकेशंस के लिए रेप्लिकेशंस क्रिएट किए हुए हैं, वो एक सर्टेन टाइम के बाद फ्रेश करते हैं कॉपीज को, ताकि वो जो दोनों एंड पे जो नोड्स हैं जहां पे रेप्लिकेशन हुई भी है वो फ्रेश हो जाएं. ठीक है. तो फ्रेश का मतलब होता है अपडेट हो जाएं. तो जरूरी नहीं होता कि वो एक साथ हो, बल्कि एक सर्टेन टाइम के ऊपर हम उसको क्रिएट करते हैं और वो फिर क्या करता है, अपडेट कर देता है. that is in the अच्छा. Second is about, next slide is about system expansion. So that is the basic phenomena we have, that always our system normally expands. सिस्टम एक्सपेंड ही करते हैं, याद रखें, सिस्टम कभी श्रिंक नहीं करते हैं. डेटाबेसेस जहां भी तुम बिल्ड करोगे वो एक्सपेंड ही करेंगे, श्रिंक नहीं करेंगे. श्रिंक सिर्फ उसी सूरत में करेंगे जब कंपनी डिफॉल्ट कर जाए, कंपनी खत्म हो जाए, उसके क्लाइंट्स ही खत्म हो जाए, कस्टमर्स ही खत्म हो जाए. अदरवाइज इफ एनी एप्लीकेशन यू आर बिल्डिंग अप, नॉर्मली इट ग्रोज. मिसाल के तौर पे लेट्स सपोज मैं कराची यूनिवर्सिटी में आज डेटाबेस क्रिएट करके सारा डेटा मैं रिकॉर्ड करता हूँ, तो ये डेटा कम तो नहीं होगा ना, बढ़ता ही जाएगा. स्टूडेंट्स आर कमिंग एंड कमिंग एंड कमिंग, तो एक्सपेंड करेगा. नादरा ने पहली दफा एप्लीकेशन बनाई एनआईसी के लिए, तो उनके पास 1-2 मिलियन रिकॉर्ड्स थे. आज उनके पास 8 करोड़ रिकॉर्ड्स हैं. तो पिछले 10 साल में उनकी जो एक्सपेंशन है उसकी परसेंटेज निकाल लो कितना एक्सपेंड हो गया है. जो नंबर ऑफ यूजर्स फेसबुक पे 10 साल पहले थे और आज देख लो कितने हैं. ठीक है. जो किसी भी एप्लीकेशन के अंदर तुम किसी मल्टीनेशनल की एग्जांपल ले लो, लिवर ब्रदर की एग्जांपल ले लो, तो वो जो डेटा आज से 3 साल पहले होल्ड कर रहे थे, जो आज डेटा होल्ड कर रहे हैं, ऑफ कोर्स सिस्टम्स नॉर्मली एक्सपेंड. ये चीज तो अपने जहन में बिठा लें. जब भी हम डेटाबेस डिजाइन करते हैं कहीं पे, तो एक इंपॉर्टेंट कॉन्सेप्ट आता है, वो आता है इशू इज डेटाबेस स्केलिंग. तो कितना स्केलेबल है, कितना बढ़ सकता है, कितना हम इसमें मजीद ऐड कर सकते हैं. तो ये हमेशा हमें ध्यान में रखना होता है, बिकॉज सिस्टम ऑलवेज एक्सपेंड एंड दैट इज बेस्ड ऑन सर्टेन प्रिंसिपल्स. इमरजेंस ऑफ माइक्रो प्रोसेसर एंड वर्क स्टेशन टेक्नोलॉजीज हैं, फिर डिमाइस ऑफ ग्रोश लॉ है जो बिलीव करता था जो एक्सपेंशन होगी वो अब एक्सपोनेंशियल जो है वो बल्कि एक्सपोनेंशियल एक्सपेंशन है. नेटवर्क के अंदर जितनी नोड्स ऐड होती हैं उसकी पावर से कनेक्शंस बढ़ जाते हैं. पता है ना आपको, ये एक लॉ है. जैसे अगर 2 नोड है तो 1 कनेक्शन है, अगर 3 नोड है तो 3 कनेक्शंस हैं, 4 नोड है तो और कनेक्शंस बढ़ जाएंगे, ज्यादा हो जाएंगे. एक और नोड बढ़ा दूंगा तो कनेक्शंस और बढ़ जाएंगे. तो ये तो मैं खैर कनेक्शंस की बात कर रहा हूं. सिमिलरली डेटा ग्रोज एज वेल. डेटा कम्युनिकेशन cost versus telecommunication cost, that is another important thing which we have to consider, that while we are expanding, while that we are talking about scalability, the cost factor is also there, because the performance of the system declines if you have not handled the scalability in a manner you should do. अगर नहीं करोगे और सिस्टम को बढ़ाते, मतलब मिसाल के तौर पे मेरे पास वही नेटवर्क है, मैंने नेटवर्क की कैपेसिटी को इंक्रीज ही नहीं किया और मैंने नए सर्वर इंस्टॉल करना शुरू कर दिए, और मेरी ट्रांजैक्शंस जो थी वो पहले 10 लाख एवरेज ट्रांजैक्शन थी, वो बढ़ के 20 लाख एवरेज ट्रांजैक्शंस हो गई, 20 लाख से बढ़ के अब वो 1 करोड़ एवरेज ट्रांजैक्शंस हो गई. तो क्या सिस्टम वैसे ही बिहेव करेगा? नहीं करेगा ना भाई. सिस्टम वैसे बिहेव नहीं करेगा, उसकी परफॉर्मेंस डिक्लाइन हो जाएगी. ठीक है. अच्छा, जितनी ज्यादा जो आज मेरे पास एवरेज क्वेरीज जो जनरेट हो रही थी, लेट सपोज वो जो है 500,000 थी, अब एवरेज क्वेरीज जो जनरेट हो रही हैं वो 1 मिलियन है. अब जो एवरेज क्वेरीज जनरेट हो रही हैं 1.5 मिलियन है. तो इसका मतलब है द कम्युनिकेशन कॉस्ट डज मैटर, योर टेलीकम्युनिकेशन कॉस्ट डज मैटर. So all that costs are relevant while we are talking about system expansion. और अगर if that cost increased, always remember, तो इसका मतलब है performance will decrease, and that will not give you the optimal results as it is required. ठीक है? That is the concept regarding the system expansion. So in this slide we will discuss. अच्छा, मैं okay, fine, I'll stop this lecture over here and I will give you a second link. After 10 minutes we'll start the next session from this slide.